Okay, so the final exam questions from the respiratory system are as follows. Let's first do the first one. What is the bicarbonate ion carbonic acid buffer system? Please write it out and label all the reactants. Where is it? And if it fails, which two body systems take over? Let's work on that one first. So first of all, I'm asking you, let's see if I can advance the slide. No, I can't. Impossible, apparently. There we go. First, let's write out the bicarbonate ion carbonic acid buffer system and label it water plus carbon dioxide. If you combine these two, you're going to form carbonic acid. And you can balance the atoms here, 2 and 2, 1, 1, 1, 2, 3 over here to make sure you have this right. This is carbonic acid. I'm writing this out before I tell you what it is. Carbonic acid, this is a weak acid, and carbonic acid can not only go this way and form water and carbon dioxide. If it goes in this direction, it's going to dissociate and break into hydrogen ions. That's what acids do in a solution. So this is our hydrogen ion. I hope you've had this equation quite a bit at this point in your life. Here's our hydrogen ion, and the other group of atoms is going to be the bicarbonate ion. That's 0 and a 3. That's not 0, that's an O. And those are all capitalized. This is the bicarbonate ion. That's what acids do in solutions. They break down to release hydrogen ions. And remember, this hydrogen ion is going to be the only thing that influences your pH, or it is the measurement of pH, the power of hydrogen. And so while other things can influence pH, like for instance, how many bicarbonate ions there are, really that's just indirectly, because it's how those other things can associate with the hydrogen ion. So this is our main player. If you have more hydrogen ions, your pH drops. Well, we want our blood pH to remain between 7.35 and 7.45. And so what is this whole bicarbonate ion carbonic acid system? And I should add another arrow here, because this can go in two different directions, meaning water and carbon dioxide combine to form carbonic acid, which breaks down to form hydrogen ion and the bicarbonate ion. If we go in the reverse, we would say the bicarbonate ion and the hydrogen ion form carbonic acid, and carbonic acid breaks down to form water and carbon dioxide. The system is in equilibrium, and so you need to know which way it's going to go. It's normally going back and forth to keep all of the parts in what we call equilibrium. But if you add a lot to this side of the equation, then the equation usually shifts, we say, to the left. If you add a lot on this side, namely carbon dioxide, you shift to the right. So what is this? The first question says, what is the bicarbonate ion carbonic acid buffer system? It is a buffer system found in the blood, that helps prevent radical shifts in pH. In pH. In other words, it's a buffer. You know, if we added extra hydrogen ions, our pH isn't going to plummet down past this area, and we would be in a situation of acidosis. Or if we take away hydrogen ions, we won't go this way and become alkalotic. So this buffer system softens the blow and helps to maintain our pH within 7.35 and 7.45. So what is it? It's a buffer system. Please write it out and label all the reactants and products. We did that. Where is it? It's in the blood. We did that. And if it fails, which two body systems take over? Well, this is our backup. It's always in the background, and it's always helping us maintain pH. But if we get in trouble because we've added too many hydrogen ions on this side, this is a key player, or too many carbon dioxide molecules on this side, we have two body systems that can help us out. And those two body systems are the respiratory system and the urinary system. Those are the two body systems. So this is the answer for the first question. You write it out, you label it, you say it's in the blood and it prevents radical shifts in pH, and the respiratory and urinary systems take over if it's overwhelmed. That's the first question. Now, the second question has to do with write out the bicarbonate ion carbonic acid buffer system. You want to write that out. You'll get one or the other of these. I would assume because you're at the end of 142, it's going to be the second one, by the way, but you need to practice the first one to just understand what it is. So the second question says, write out the bicarbonate carbonic acid buffer system. A patient has COPD, and I'm giving the example of emphysema. And if you remember, with emphysema, we retain carbon dioxide. So how would that affect the patient's pH, blood pH? And how is the system overwhelmed? Here we go. Let's start there. I need to pause to add another slide. Okay, I went ahead and pasted the question on here so it would be easier, and I wrote down the equation so it would be neater. It's hard for me to write in the first place because I have no handwriting skills, and so there you go. So the first part of this question says write out the bicarbonate ion carbonic acid buffer system and label all the parts. We did that. Now, how, if a patient has COPD, how would that influence their blood pH? So blood pH, remember, is supposed to be between 7.35 and 7.45. If we get more hydrogen ions added to our blood, our pH can fall. And if we get fewer hydrogen ions, then our blood pH can increase. Well, with the case of someone with COPD patients have elevated carbon dioxide levels because they're in their lungs, like especially with the emphysema, the alveolar walls break down between them. And so they literally trap, you can think of it as when they can breathe in, but when they're trying to breathe out, those massive alveoli now with the walls completely destroyed, sort of cave in and hold the carbon dioxide. So COPD, they have elevated carbon dioxide. First of all, so someone has COPD. How would that affect their blood pH? Well, I'm going to explain it in this way. If we add more to this side of the equation, which we are, in the blood, someone with COPD has elevated carbon dioxide levels. So what's going to happen is the water forms with carbon dioxide to form carbonic acid. And now say we still maintain this carbon dioxide, then we're going to have elevated amounts of carbonic acid. So how can we get rid of it? Well, we can go in this direction and break it down. And so what we end up with is more hydrogen ions. That's what we end up with in the end. So ultimately, how does having COPD affect their blood pH? COPD patients have lower blood pHs. Not always, because if their body's compensating, but this is the potential. It drops the pH because we're adding hydrogen ions. If we add carbon dioxide to get rid of it, then we combine it to form carbonic acid, and then we have more of it. Now we have to stay in equilibrium, so it's going to break down and produce more hydrogen ions. The more hydrogen ions you have, the lower your pH. So COPD have, oh my goodness, have lower blood pH. Now, I would put that in an actual sentence. I don't know. I was talking and writing at the same time, but COPD patients have a lower blood pH. And how is the buffer system overwhelmed? It says, exactly how is the buffer system overwhelmed? Well, you add, let's see where I am. You add carbon dioxide and the equation shifts to the right. Notice we are shifting to the right to try to get rid of that carbon dioxide. Add carbon dioxide and the equation shifts to the right. Shifts to the right and increases hydrogen ions, therefore decreasing pH. All right, well, so then my next question is, if someone has a lower blood pH due to elevated carbon dioxide, what is this called? Well, because our respiratory system is the problem, we know that we have two systems. If this buffer system gets overwhelmed, we have the respiratory system and the urinary system that can help us out. Well, if our respiratory system is messed up because we have COPD, et cetera, we know our respiratory system is the problem and it's not coming to the rescue. And so in this case, it says, what is this called? If your buffer system is overwhelmed and your blood pH drops because of the respiratory system, this is called respiratory acidosis. Respiratory acidosis, because it's caused by the respiratory system. So now in this case, which body system can correct this change in dropping pH? Well, if the respiratory system is messed up, the urinary system is the one that's going to have to come to the aid. Urinary system tries to fix the situation. And then I ask, what is this called? It's not just fixing the situation, it has a name. What is this correction called? Well, it has to do with the renal system, the urinary system. So this is called renal compensation. Now let me tell you what this basically means. Is this. If you're in respiratory acidosis, that means you're retaining carbon dioxide and increasing your hydrogen ion levels in your blood. And if you increase the hydrogen ions, the pH is going to drop, and the urinary system or the renal system is going to have to compensate and get rid of those hydrogen ions. And by getting rid of, the last one is, how does this body system accomplish normal pH? The renal system or the urinary system releases hydrogen ions in urine. So we take those hydrogen ions out of the blood and get rid of them, just eliminate them from the body altogether. The renal system will learn in a future chapter that also what it can do is it will retain bicarbonate ion. It does that as well. But ultimately, it gets rid of those hydrogen ions in solution. So quickly said again, when a patient has COPD, their pH drops because they have elevated carbon dioxide, which leads to elevated hydrogen ions. Well, the renal system is going to have to take over and fix the situation, and the term for that is renal compensation. And the way that the renal compensation occurs is that the urinary system releases hydrogen ions into the urine, takes it out of the blood, puts it in the urine, and hopefully our pH will go back within normal range. So if you take the blood pH of someone with COPD, it doesn't mean they're going to be up here having acidosis or being more acidic, because if their urinary system is compensating, then it keeps us within that normal range. So that's what you have to be aware of. If somebody's in respiratory acidosis, they can have renal compensation, and you might not see anything in their blood pH, any differences. Okay, I hope I answered everything. And if you have any questions, of course, let me know.